So here's our double concave lens. Again, that means it's just concave on both sides. So let's say we send in a parallel beam. It's going to be kind of the guiding theory of this lens. So remember, it's air out here and glass in here and air out here. So this light's going to come in. Here's our normal. Should it bend towards or away from the normal? Towards the normal, right? So in this case, in this drawing, does that mean it's going to bend up or down? Up. So our normal is up. And then the opposite's going to happen here. Now we are large index to small index. So does it bend away or towards?
Away.
Away. But notice that since our normal's changed, we're just going to bend it up again. So it's going to bend up, up. Same thing here. We're going to bend down, down. Okay? Let's just draw on a few other ones. Up, up, down, down. What happens if I send it right down the middle? Hits right on the normal. Just going to keep going. What do you notice about these 5 beams?
Diverging.
They are diverging, right? So we sometimes call this a diverging lens. And actually, that's the generic term for anything that does this. We call it a diverging lens, whether it's double concave or not. Okay? So notice this one. If you try to go outside and burn stuff with this type of lens, is it going to work?
No.
No. And most of you, probably the glasses you wear are diverging lenses, and so you can try to burn ants all you want with these. This is not going to work. Okay? It's going to spread the light out. However, if you look at this, here's our eye looking at this, it will appear like this light's coming from somewhere back here. So if I draw all these back this way, notice what happens. So this does have a focal length. It's going to be right here. So often we'll call this a virtual focal length because, well, it's not, again, it's not actually focusing the light. Yeah, Ryan?
Do flashlights, light sources, use double concave lens to project light out?
Well, most of those use mirrors. They don't actually use lenses, but you know, if you do have a focusing thing on it, then they would use a, yeah, they'd want to focus it with a real image, not virtual. So the big thing with this, just like when we had virtual focal lengths with the mirrors, what do we do to this mathematically? We just make sure that it has a negative focal length. And again, those of you that wear glasses, like I said, most of you have these type of lenses. So if you have contacts especially, you could go home tonight and look at the focal length on the little box of contacts. It's going to tell you the focal length, and it'll be negative. And that means that you use diverging lenses for your contacts. Okay, remember there are focal lengths on both sides. If you reverse them around, you're going to get focal lengths on both sides.